Welcome to Control4 Driver Development Essentials. My name is Peter Casenza. In this video, we will walk you through the steps required to create a Control4 driver for a security system. In doing so, we'll use two tools delivered by Control4 to assist with the driver creation. The first is Driver Editor version 3.0. This latest version of Driver Editor is a driver development environment that provides a graphical interface for the creation and modification of C4Z files. It is important to understand that Driver Editor 3.0 and all subsequent Driver Editor releases are compatible with C4Z files only. If you are new to C4Z files, we'll discuss them in the beginning of this video. The second tool we'll use is Control4 Security Controller Driver Template. Control4 is currently in the process of delivering driver templates for many of its more heavily used proxies. Driver templates are delivered with Driver Editor. When a template is selected and loaded into the Driver Editor environment, it offers a powerful development scenario that can reduce development time as well as improve code quality. In this video, we'll use a template specifically designed to help create security controller drivers. In viewing this video and all videos found in the T201 series, it is expected that you be familiar with the architectural and development concepts outlined in the driver development training modules. This includes the 201, 301, 401, and T101 video series. You may find it useful to review the information offered in those training modules before proceeding to develop template-based C4Z files. Before we begin creating a driver for a security system, it might be useful to briefly discuss C4Z files. Beginning with Operating System 260, Control4 has changed the file structure previously used to support device drivers. Up until 260, device drivers were contained within a single file using the extension of C4I, or drivername.c4i. The release of 260 marked a significant change to this model with the introduction of the C4Z file structure, or drivername.c4z. A C4Z file provides all of the content that the C4I file previously did. However, it offers some significant features and advantages that its predecessor did not. At its most basic level, a C4Z file is a zip file. It contains numerous folders and files which, when encapsulated inside a C4Z file, represent a device driver. The modularity within the C4Z file enables a far more organized and structured approach to device driver architecture. It also provides the ability to include many related objects within the confines of the driver in an organized manner. These objects include items such as graphics and icon directories to support custom user interfaces, which can run on Navigator. A C4Z file also contains one or more Lua files, which contain all of the driver's Lua code. Control4 driver templates take advantage of the C4Z structure by delivering libraries of commonly used Lua functionality. These can now reside in one directory location and be easily referenced. A C4Z file has its own XML file, which separates the XML portion of a driver from the Lua code. Additionally, rich text documentation can be included in the C4Z to support a far superior user assistance model. Now, let's talk more specifically about security. Control4's approach to handling security system control, as well as the supporting driver development, has also changed with the release of Operating System 2.80. The security proxy itself has gone through extensive re-architecting. It has been broken into two separate proxies, the new Security Panel proxy and the new Security Partition proxy. Before we get into the nuts and bolts of security driver development, let's talk about some of the terminology you'll hear while watching this video. Security Panel. In Control4 terminology, and generally speaking, a security panel is a wall-mounted unit that manages the various items found within the system. These items might include motion detectors, smoke detectors, and window and door contacts. Security partition. A security partition can be looked at as an independently monitored and controlled area within the security system. Partitions are useful as they can provide organization and the ability to set unique security settings to areas of a home or building. The amount of security partitions that can be supported with your driver is dependent on the capabilities of the security panel. Security system. When we refer to a security system in this video, we're talking about both the security panel proxy and security partition proxy elements. Security zone. A security zone in the Control4 system represents an installed and configured security device. Zones belong to the panel and are assigned to the partitions. Using zones to represent physical devices in this manner is useful. For example, consider that a home may have a first floor that has a front door sensor and several windows that have sensors as well. Treating each security device as a zone allows for flexibility, such as allowing the windows to be open while still monitoring the door state. Bypass. This term refers to the ability to deactivate specific zones of a security partition. Bypass zones allow for that zone to be unmonitored while the rest of the partition is monitored. Faulted. Faulted refers to the state of a zone where the zone, for various reasons, is unprotected. A faulted state can come from low batteries on a monitoring device or a faulty sensor. Faulted can also mean that the zone has been breached, such as a window with a contact sensor is currently open. Normal. A zone state of normal means that the zone is not in a faulted or bypass state and is able to be armed. The security panel proxy is intended to work in tandem with the security partition proxy and potentially multiple instances of the security partition proxy. The previous security proxy, pre-280, was essentially a proxy just for partitions. These new proxies support the definition of protocol drivers for various security systems as multi-proxy devices with one instance of the security panel proxy and numerous instances of the security partition proxy. The amount of partitions a driver should support is dictated by the security panel. And while the partition portion is technically a new proxy, all of the commands and states in the previous security proxy are retained and supported. However, some commands and states will be deprecated for purposes of supporting the new security UI. Elements that will be deprecated in the future are identified as so in the 280 Proxy and Protocol Guide. While these elements may currently be supported, Control4 recommends excluding them from any new driver development efforts. Drivers using the new security system proxies will usually be modeled using multiple proxies. Only one instance of the security panel proxy is used to handle global items such as individual user account management, general panel attributes such as trouble states and system clock control. Additionally, the panel proxy handles the management of individual zone definition and state tracking. In addition to the main security panel, one security partition proxy is added for each partition that the panel could potentially support. The security partition proxy is used to handle partition-level functionality like arming, disarming, emergency, messaging, and zone membership. Typically, for residential projects, the most common use case would be for the home to have only one partition configured on the panel. This means that there may be partitions added to the project which are not necessarily active. In this scenario, a master isActive variable has been included to indicate whether or not a particular partition is being used. While we'll discuss the use of this attribute in detail later in this video, it is important to write your driver to support the maximum number of partitions supported by the security panel. If it is possible to programmatically detect when a partition is not used, you can mark it as disabled via your driver. A small security system with a panel and two partitions would look like this. The security panel proxy handles setup and general functionality for the entire security panel, while partition proxy number 1 handles arming, disarming, and alarms for partition 1, and partition proxy number 2 handles those responsibilities for the zone in its partition. The security template supplied by Control4 defaults to including 2 partitions. You may need to add additional instances of the partition proxy to match your security panel. The security panel proxy also provides support for Control4 sensor bindings for each sensor zone and relay bindings for each controllable zone. As a driver developer, you will need to include support for these in your driver, as integrators will be adding these types of device drivers to projects while configuring the security system that includes your driver. Note that the bindings for these zones are dynamic and will be created as zones are added to the system by the driver. As mentioned earlier, the graphical interface for the proxy has been completely redesigned and offers an informative and interactive control experience for the user. The last item to consider before we begin driver development is the protocol information for the security controller for which you wish to create a driver. It's important to obtain the latest protocol document from the controller's manufacturer. It will provide you with the device's communication syntax and notifications it will send to Control4's new security controller proxy. Now, let's open up Driver Editor 3.0 and take a look at the new security controller template and discuss what's required to write a security panel partition C4Z driver. From within the Driver Editor toolbar, we'll select File and hold our mouse over the New menu option. Here, we are presented with several choices. In this demonstration, we're going to create a new driver project, or C4Z file, based on an existing template. So we'll select the Driver Project from Template option. When we do, we can see the Security Proxy Template C4Z file. At this point, it's worth explaining a driver editor construct that is important to understand. Driver Editor 3.0 views C4Z files as a project. When a C4Z file is loaded into its environment, it organizes the C4Z into a structured project and displays it in the Driver Project window. Due to the organized structure of a C4Z file, it's easier to consider our driver as a project while working in the Driver Editor 3.0 environment. This is also a good time to discuss where Control4 driver templates reside on your system. Driver templates are delivered by Control4 through the Driver Editor development environment and will reside in the following directory. See Program Files, Control4, Driver Editor 3.0, Templates. You will also find a driver template directory in this location. See User's Username, Documents, Control4, Driver Templates. This directory is created for you to store driver templates that you have customized or created on your own. It is important to keep these templates separate from the Control4 supplied templates, as the Driver Editor Templates directory is overwritten upon an update of Driver Editor. Now let's double-click the template file to open it. When we do this, we are presented with a screen that indicates the name that Driver Editor will assign to the project it creates while we're developing our driver. We'll call our project Acme Home Security Controller. Driver Editor also shows us the default location where it will save our project locally. Clicking OK will load the template into Driver Editor and create the driver project for us to begin building our security controller driver. The first thing you'll notice is the driver project area of the screen. Here is where we can see the project framework that is provided through the security template. Well, at first glance, it may seem like there are lots of files and directories. It's actually numerous Lua files organized by purpose. Some of them are in libraries. Our driver's XML file, and one rich text file. If you are familiar with the C4I file structure, all of this would have previously resided at one level within the confines of a single C4I file. If you want to open one of the Lua files in the project, simply click on it and its contents are displayed in Driver Editor's editing window. For example, let's open the project's main driver.lua file. This file is significant as it contains all of the require statements for our driver, as well as the initialization code that is executed when our driver loads. We can also see our driver's XML content in the window by opening the driver.xml file. When we double-click the file, we can see the high-level XML in the driver configuration window. Many of our driver's XML information is edited by double-clicking on any of the top-level elements. This displays Driver Editor's XML editing screen. Here, numerous XML entries can be modified and easily saved in our driver project. The more complex XML elements can also be opened and edited in the driver configuration screen. For example, if we open the proxies XML entry, we can see a high-level view of its contents. Double-clicking on the proxy value will display the proxy editing screen where changes can be made and saved into our project. You will find that the UI in Driver Editor presents XML based on the data types and amount of data that a particular capability contains. For example, if we go into Capabilities and double-click on the CanSetTime element, you will see the Driver Editor displays a window for adding, deleting, or editing the capabilities that our security controller supports. Let's go back into Driver Project and look at one more file. If I close the driver configuration screen, Driver Project reopens. Here is the documentation RTF file. Double-clicking on the file opens an editing screen which supports rich text formatting. Font assignment, images, and hyperlinks are all supported in this area. This provides you with an excellent opportunity to deliver quality driver documentation to integrators who are using your drivers in commercial or residential systems. Now, let's begin to modify this template and turn it into a publishable C4Z file, which supports a security controller. In this section of the video, we'll show you examples of each of the development steps to complete the driver. These include adding panel and partition commands, adding panel and partition notifications, adding driver-specific functions delivered through the UI, updating the XML for a driver, adding documentation to support our driver, building the driver in Driver Editor, validating the driver in Driver Editor, and finally, publishing the finished C4Z file. After watching these demonstrations, you should find yourself in a good position to develop your own security system C4Z driver. Now, let's take a look at how we can modify the proxy commands supplied within the C4Z template for the security panel. When we talk about these commands, we are referring to security panel proxy commands that are received by the device through the Receive from Proxy API. If we open the SecTemplate Communicator Lua file, we'll see all of the security panel and security partition proxy commands defined within the template. These will need to be modified to include the device-specific protocol information for each command. Keep in mind, these commands will be sent from the UI to our device, so we'll need to build each command in a manner that when our security panel receives it, it will understand the information being sent inside the command. For example, here we can see that the template has a security partition proxy command for arming the partition. The command is called seccom send arm partition. Right now the command is empty, but we can see from the documentation that it sends the partition index, arm type, user code, bypass, and interface ID parameters. After modifying the template, our new command now looks like this. Once all of the proxy commands have been built, we can move on to handling any functionality that is unique to the security controller with which we are working. All messages sent from our security panel need to be parsed into a format that the Control4 security proxy can understand and be handled correctly by our driver. Because we have the controller's protocol documentation, we have a good idea of what these messages will be and how they will be formatted. In many cases, the data these messages contain will impact what is displayed on the system user interfaces through proxy notifications. Our driver receives communication from the panel inside of the device messages Lua file, specifically inside the getMessage function. The communication is broken into logical chunks and sent to the handleMessage function. HandleMessage is responsible for taking the communication block given to it by getMessage and identifying it into a unique function and parameters. Once this is done, those pieces are now sent to dispatchMessage, where the appropriate driver developer called devMessage function is executed to issue the right calls to update the state information of the system. If we open that file, we can see that all of the security proxy notification wrapper functions are here. Keep in mind, there is no need for us to edit any of these. Rather, these notifications will be called after we parse the message from the device and create the new function in devMessage. Our new function will call the appropriate predefined notification, which is then sent to the proxy using the send-to-proxy API. Let's take a step back and see how this happens. All parsing of messages from our controller happen inside the device messages Lua file. If we open the file, we can see that a sample function has been included. It's called ZoneData, and a function like this is sent when your driver is getting zone configuration information from the security panel when zone information changes, specifically the zone ID value, the zone type, and the zone name. Your job as a driver developer is to parse the incoming messages from the security panel into a format that can be sent to the Control4 proxy and displayed as usable data on the user interface. If a device sends multiple messages within one response string, each message will need to be parsed into a single function for processing inside of getMessage and then sent to handleMessage. All parsing of single device messages is done using the handleMessage function in the device message Lua file. Using ZoneData as an example, let's consider a message that comes from the security panel whenever the information changes. We want to use the data in that message to update our UIs with the latest security system configuration information. The incoming message looks like this. We see a command name, zone_data, and then we see 3 parameters encapsulated in parentheses, and these parameters are comma delimited. Without modification, this means nothing to the security proxy. We need to parse the incoming data, which can then be sent to the security proxy through the 2 functions called here, setZoneInfo and addZoneToPartition. The setZoneInfo function passes the zone's ID value, type, and name to the proxy to update the UI. The addToZonePartition function associates the specified zone ID with the given partition. This is how we identify that a particular zone is part of the partition. Without this call, the zone would not be visible in the UI for that partition. Another example function included in the template is ZoneStatus. The ZoneStatus example shows you how to handle zone-specific data coming from a specific zone, such as a fire alarm or a door sensor. In our example, zone status passes three parameters with it: the zone ID, the state of the zone, such as opened or closed, and whether or not this zone has been flagged as bypassed. Once the zone data from zone status is parsed by the driver, we can see that it calls setZoneState to pass the data up to the security proxy and setZoneBypassState with the current bypass state. The last example included in the template is a sample function coming from our security panel called PartitionState. PartitionState is a function that comes from the security panel, and it contains information pertaining to a particular partition in the system. It includes the partition ID, the state of the partition, such as armed or disarmed, the state type, which specifies which type of arming or alarm the partition is currently experiencing, and finally, two timing parameters that reflect the delay values used for entry and exit delays for the partition. We can see further below in the function where the setPartitionState notification is called. This sends the parsed data for the PartitionState function up to the security proxy. Once we have handled all of the messages that the security controller sends that require being sent up to the UI in this manner, the Lua development work for our proxy notifications is complete. The security template allows for you to include functions with which the end user can interact on the Control4 user interfaces. These functions are defined by you, the driver developer, and are displayed under the Functions button on the Control4 Security UI. In this section of the video, we'll discuss how you can take advantage of this feature in the template. The first area we'll look at is the Capabilities section of our template. Here is where these functions are defined. Note at the bottom we have a capability named Functions. The entry for this capability is a comma-delimited string, and you can enter as many functions here as you wish. In our example, we see a user function 1, user function 2, and a function named clear trouble or alarm for a total of 3 functions. Each of these will be displayed on the UI under the Functions menu when selected by the end user. Now that we've defined the functions we wish to display on the UI, let's look at the driver functions Lua file in the template. When a user presses one of the functions on the UI, the functions that are created in the driver functions file are called. For example, remember we created 3 functions in the capabilities section of our drivers XML: user function 1, user function 2, and clear trouble or alarm. Here you can see where we have created a function for each of those in the driver functions Lua file. The first 2 functions are fairly simple. You can see here where we are displaying a simple string on the UI for each of these functions. For example, if the user presses user function 1 called is displayed using the display partition text function. Let's take a look at the clear trouble or alarm function to see how a more complex function can be created. Let's consider an example where the alarm system has been tripped by the end user due to inadvertently entering the home while the system was armed. We want our driver to display a keypad on the UI for the user to enter their code to stop the alarm. We can do this with the clear trouble or alarm function we are creating, along with the template function partition request additional info. When the user presses the clear trouble or alarm button on the UI, partition request additional info is called through the clear trouble or alarm function. When this happens, the user is presented with a keyboard displayed on the UI. This allows the user to enter their 4-digit user code. Note the prompt at the top of the keypad. Here is where the text is defined in the function. Prompt allows you to customize a message displayed here. The function name element allows us to include the function that needs to be called when the user enters their security code on the keypad and presses Done. The masked data element dictates whether or not the security code numbers are hidden as they are entered. The last part of developing this function is understanding the role of a function included in the template called processAdditionalInfo. That function resides in the sectemplate communicator file. Remember the function name value we entered when we defined our clear trouble or alarm function in the driver functions file? When the user presses the Done button, processAdditionalInfo is called, and we can see here that one of the parameters for that is its function name. Here you can see that we've added the code for that function. Another parameter worth noting at this point is newInfo. In this example, newInfo is the code the user entered through the keypad. Here we can see that the user code has to be 4 digits. This code tests the length of the code, and if it is not 4 digits, the following prompt is displayed. Once the user enters the correct code, our function sends a command using sendCommand. You, as a driver writer, will need to fill in this value with the command to clear trouble for the partition within the security panel you are creating a driver to support. For example, we would send an off command to our example security panel to turn the alarm off. Now, let's take a look at the XML portion of our driver. As we stated earlier, there is only one XML file in our project, driver.xml. Note that the driver XML file cannot be changed in the template, as Driver Editor expects a driver.xml to be presented when it builds our C4Z file. That file is edited through the driver project screen on the right-hand side of Driver Editor. The security controller for which we'll be creating a driver in this video is the Acme Home Security Controller, so we'll change the manufacturer and model fields to reflect that. Next, we'll name our driver. This entry is important as it will be displayed in places where users will be looking for our driver. A driver name should be descriptive and informative. We'll name this driver Acme Home Security Controller. We'll leave the creator value unchanged for our purposes, but this entry could be a developer name or company name. Next is the version field. Since this is our first iteration of this driver, we'll leave the version at 1. However, you can start your versioning as you see fit, as long as the version numbers used are integers. We can also update the created entry. This is useful as it provides a date stamp when our driver development was initiated. You can modify the time and date elements by highlighting each and using the arrow buttons. You can also set the field to the current date and time by clicking on the plus icon. The modified field functions similarly to the created entry and offers you a way to assign a time and date stamp to future driver modifications. We'll set our modified value the same as our created entry. You can also set the modified date element on a system-wide level under the Tools Options menu. Select Dates, and you're presented with 3 choices for how the modified date will be populated. Manually, as we have just demonstrated, upon saving a driver, or you can choose to have the field updated upon publishing the driver. Those are all of the changes we need to make on the main page for our driver. All of the remaining values are set correctly by default for us from the security proxy template. At this point, we've configured all of the high-level information for our driver. Next, we'll take a look at the proxies. Here we see that the template includes 3 proxies, including 1 security panel proxy and 2 security proxies. It is important to note that your completed driver only requires 1 security panel proxy. A security proxy is required for each partition that your panel supports. So, there's nothing more we need to do here unless you wish to change the number of partitions that your driver will support. When we open the capabilities, we see that there are entries for all of the capabilities supported by the security proxy. We can see that our template supports the following capabilities. We can add a capability by clicking on the plus icon at the top of the Driver Editor window. This displays the Capabilities Edit screen. This level of the screen lets us edit any of the provided capabilities. If we want to add a capability, we need to click on the plus icon in the bottom right-hand corner. Here we can name our capability, designate the type of value it supports, and include its acceptable values. We can also add a description of the capability here. If we save this capability, it will be included in the list displayed in Driver Editor. Next, we'll take a look at the Connections tab. You will notice that there are 6 connections included in our template, including one RS-232 control connection, 3 proxy connections, and 2 room selection connections. One room selection connection is required for each security partition proxy connection. The security panel proxy does not require a room connection. Note that the connection IDs fall into the correct range for each respective connection type. For example, proxy connections are in the 5,000 range. Also note that valid class names have been included with each connection. For example, security panel for the panel proxy and security for the partition proxies. The security template supplies all of the necessary connection information for our driver by default. You would only need to edit the connections to match any changes made in the proxies section. Earlier in this video, we modified the config section of the driver XML to support device-specific commands. Other elements in this section include identifying our driver documentation support file, as well as defining logging levels and data polling intervals. In most cases, these elements will not need to be modified when creating a driver. Finally, we'll include some documentation with our driver, which will help integrators with setting up and configuring the driver. To do that, we'll open the documentation.rtf file and either copy pre-existing content into it or create it right inside the window. This content will be displayed in Composer Pro under the Properties Documentation area for our driver. At this point, we've reviewed and modified all of the key components of our driver project. Driver Editor provides several tools for us to finalize the project and eventually publish it as a working C4Z file. The first step in this process is building the C4Z project file that we've been modifying. The build process does several things. First, it saves all of the files in the project. Then, it creates a C4Z file from the list of files found inside the driver editor under our C4Z proj file. To build our project, we'll open the Project tab from the toolbar and select the Build option. Alternatively, you can use the shortcut key of F6. When the build of the project is complete, the output window is updated with the results. The next step in our process is to validate our newly created C4Z file. It is important to understand that a project must be built before it can be validated. If you select Validate before building, Driver Editor will force a build of the C4Z proj file to create a C4Z and then perform the validation. The validation step is useful as it leverages a set of generic tests supplied by Control4 and delivered within Driver Editor, which reviews the driver XML file for correct XML structure and valid content. It also compiles all of the Lua files and validates them for correct syntax. To validate our C4Z file, once again open the Project tab from the toolbar and select Validate. F7 will also initiate the validation process. Before validation begins, you can set the verbosity level of the validation process, as well as the level at which logging will be displayed in the output window once validation has completed. Verbosity level gives a listing of the tests that were performed against our driver, as well as their status of pass or fail. Let's select the Most option here, as this setting will provide us with additional information in the event that a test fails. We'll select Debug Logging Level, as we'd like to see any log content that will help us figure out where an issue may be within our driver. Clicking the Validate button begins the process. Here we can see the log file contents of our C4Z validation. The log shows us all of the tests that were run against our XML and Lua code, as well as the results. Using Driver Editor, we have built the C4Z driver from our C4Z proj file. Next, we validated the C4Z for invalid content. Now we are ready to publish our finished security controller driver. The publish function in Driver Editor is useful as it places the finished C4Z file in a designated area which can be devoted to completed drivers. You can designate this directory by clicking on Tools from the Driver Editor toolbar. Select Options followed by Workspace. Here you can designate a target directory for building your C4Z proj files into C4Z files, as well as where the publishable drivers will reside. This concludes the template-based security controller driver video. Keep in mind that you may find features in your security controller that are not explicitly supported by the Control4 security controller proxy. These features can still be supported by using custom driver properties and device-specific commands. These topics have been covered in previous training videos if you are not familiar with these concepts. We hope that you have found the information presented here informative and helpful in assisting you with developing Control4 drivers to support security system control.